Hi everyone. Today we will presenting on the core concepts computer architecture with the specific purpose of the system security protection and network design. So let's begin. Security and protection services in operating system. The first one is definition of security and protection services. Security services in operating systems ensure that data and system resources are protected from unauthorized access and malicious threats. Protection services manage how processes and users interact with system resources, ensuring safe execution and data integrity. The first one is confidentiality, prevent unauthorized access. Second one is integrity, ensure data is accurate and unaltered. Third one is availability, ensure systems and data are accessible when needed. The first question is define the concept of security and protection services in operating systems. The answer? The concept of security and protection services in an operating system refer to the methods and mechanism used to protect systems. Security ensures that only authorized users can access the system and its data. Protection control how programs and users use to system resources safely. The second question is describe the authentications, authorization, and encryption mechanism that enhance system security. For the authentication, the process of verifying the identity of a user or system before granting access. For authorization, controls access to resources and prevents unauthorized actions. For encryption, the process of converting data format to prevent unauthorized access during storage. The third question is discuss how access control, policies, and privilege management protect system resources from misuse. Access control policies is access control privileges that determine who can access which resources and only authorized users can view and modify specific data or system components. The protection of benefit is to prevent unauthorized access, data leaks, and system tampering. For the privilege management is the process of managing and monitoring the access rights of users within a system. It ensures that every user has only the permissions required to perform their specific duties, a concept known as the principle of least privilege. For instance, a normal user might be allowed to read files and while only administrators can install software or modify system settings.
For the fourth question, explain the importance of implementing auditing, monitoring, and backup strategy to prevent and recover from security breach. Auditing involves keeping detailed record of user activities, system changes, and access attempts. These logs help identify unusual or unauthorized actions, making it easier to trace and investigate incidents. Monitoring continuously observe system operation and network traffic in real time. It allowed administrators to detect suspicious behavior early, respond quickly to potential threats, and maintain system performance and reliability. Backup strategies ensure that copies of important data are regularly stored in secure Question. In the event of data loss, corruption, or cyber attack like ransomware, backwards allow organization to restore system and recover information with minimal distribution. B. A medium-sized company named Technova Solution is expanding its operation across 3 floors in new building. Each floor houses different department. Choose any network topology and visualize the network topology for each floor network solution with diagram. So today I'm choose the topology. The first floor is administration and human resources. Administration and human resource contain computer a wireless access point and with a printer. All these devices are connected to the first floor. Switch to which manage the network communication between them. So the second floor is software development and R&D. The R&D in software has several computers with printer, a server, and wireless access point. All devices connected to the floor 2 switch. For the floor 3, customer support and sales. For the customer support and sales, includes multiple computer, a server, and wireless access point. All connect to the floor 3 access points. The server could store customer database or call tops. Question 2. Describe instruction set, mission, and assembly language. Instruction set, the complete list of mission instruction a processor support which group by function. The second is mission language. The binary opcodes and operand encoding that the CPU actually executes. For the third, assembly language, a human readable textual representation of mission instruction, the assembler converts those mnemonics to mission code.
Question, which is arithmetic instruction. Perform numeric operation, which is add, sub, multiply, divide. Max 68,000 supports byte, word, and long sizes, which is BWL. For example, add B D0 D1, X byte of D0 into bytes of D1. Multiply W, unsigned 16 times 16, which is 32 result. And divide W, 32 divide 16, quotient in low word, remainder in high words. 42. Data transfer. Move or copy data between register and memory and between register. Size qualified with BWL. For example, move B D0 D1 copies the low byte from D0 into the low byte of D1. Upper bytes of D1 remain unchanged. Move W 72. D1 moves from immediate word into D1. And the third one is logical Boolean instruction. Bitwise operation for mask and flags and or EOR, XOR, and NOT. These operate in byte, word, and long and affect only the specified size. B affect only low bytes. Example, NB 3E D1 and D0 from the notes. And the C question, which is find D1 value after instruction execution below. First, the instruction move B D0 D1 copies the low byte from D0 into D1. Since D0 low byte is 15 base 16, D1 becomes 000000 15 base 16. Next, add B25. D1 add 25 in decimal, which is 19 base 16 to D1. When we add 15 base 16 and 19 base 16, we get 2E base 16. So D1 becomes 000000 2E base 16. Then sub B D0 D1 subtract D0 low bytes 15 base 16 from D1's low bytes 2E base 16. The answer is 19 base 16. So D1 becomes 000000 19 base 16. After that, multiply W D0 D1 multiplies both 16-bit values. D0 is 21 in decimal and D1 is 25. And their product is 525, which is 020D base 16. So D1 becomes 000000 20D base 16. Next, divide W 00005. D1 divides D1 by 5. 525 divide 5, which is 105, which is 0069 base 16. So D1 becomes 0000069 base 16. Then NB 3C D1 performs a bitwise and between 69 base 16 and 3C 16. The result is 28 base 16. So D1 is now 0000028 base 16. After that, OR B D0 D1 performs a bitwise OR between 28 base 16 and 15 base 16, giving 3D base 16. So D1 becomes 0000003D base 16. And the last one is EOR B 25. D1 performs a bitwise XOR between 3D base 16 and 25 base 16, giving 18 base 16. So the final value in D1 is 0000018 base 16. Thank you.